How do people react to price changes? Well, it depends. At the gas station, people are not very reactive. You often see people fill up their gas tanks regardless of the price. After all, gasoline is a necessity and has no substitutes. You must get to school. You must get to work. Also, you cannot fill up your gas tank with anything else but gasoline. This is not the same type of behavior we see in farmers markets. After all, there is more choice involved, not only in products but also where you want to take your business. Markets are usually filled with many vendors that compete for customers. So how can we explain this behavior? The answer is elasticity of demand. Elasticity of demand measures how responsive quantity demanded is to a price change. As the formula shows, we measure this by calculating the percent change in quantity and dividing it by the percent change in price. Let's do an example with the top graph. In the graph, we already have the percentages, so we can just plug them into the formula. Our elasticity of demand will be the percent change in quantity, which is 15%, divided by the percent change in price, which is 10%. This will give us 1.5. The percentages cancel off. One thing to remember about elasticity of demand is that it has no units. So, this is a fairly easy example because the percentages were given. What if we don't have the percentages and all we have is the demand curve with information about the quantity and the prices? For this, we refer to the example on the bottom graph. Let's take a look. In this case, we have an elasticity of demand formula called the midpoint formula. You might be wondering why this formula doesn't have a percent change or something that looks similar to what we've done before. The answer is a bit complicated, but we can summarize it like this. The elasticity you would get from going from point A to point B should be the same as if you were calculating from point B to point A. However, if we use a basic percent change formula, we won't get this result. So the way that we solve it is we use the midpoint approach shown in this formula. With this formula, the direction of the change in price does not matter. For the elasticity of demand, first we need the change in quantity, shown here. So, if we're going from point A to point B, then all I have to do is subtract 12 minus 8, and that will give me a 4. The bottom part of that fraction says that you add Q plus Q prime. So, in this case, we are going to take 8 plus 12, which equals 20, and divide it by 2. We now have the first part of the formula. Second, we are going to look at the change in price. Now, since we are going from point A to point B, this technically would be a 200 minus 250, which would give us a negative 50 dollars. However, as we discussed above, we can forget about any symbols such as dollar signs because elasticity of demand has no units. And secondly, since it doesn't matter if we go from A to B or B to A, we do not care about the minus sign. So we can forget about the negative sign and we can forget about the dollar sign. This will give me a 50 divided by 200 plus 250 is 450 divided by 2. If I turn my answers into decimals, this is what I get. This means the final answer for elasticity of demand in this second example is 1.81. This is how we calculate elasticity of demand.